by Oodles. We will be covering key questions for P5 end of year exams for everybody. Alright, so I'm Coach Jeremy, so I will be bringing you through the questions tonight. Now let's take a look at the first question here. Now in the first question, this question is a question this question is a question that is related to the topics of decimal numbers. So let's take a look at the question. So it reads 8.26 is equals to 8 plus x over 10 plus 3 over y. And we are supposed to find what values do x and y represents. Alright. So now these questions, it looks very simple. Basically this question is testing you on two concepts. Alright, two important concepts. The first one is actually on the place values, your understanding of place values for decimal numbers. And the second one will be on the conversion of fractions to decimal and the other way around as well. Okay, so now let's take a look at the number. So let's write out 8.26 here. So when we look at this and we look at it according to the place value, you will realize that, okay, 8 is in the ones place, which gives us the whole number 1. So 2 here actually has the value of 0.2, and finally 6 you have is actually 0.06. So from here, let's convert the decimal numbers into fractions. Alright, so let's look at it. So when we look at the whole number remains as it is, so 0.2 will actually be 2 over 10, while 0.06 will actually be 6 over 100. Alright, so this is how we first convert from decimal to a fraction. And let's take a look at the numbers. So by observation, you will realize that x over 10 is actually represented by 2 over 10 here. So very quickly we know that x over 10 will be equals to 2 over 10, and by comparison we will know that x is actually equals to 2. Now let's take a look at the other decimal numbers, 3 over y. But what we see here is 6 is actually 6 over 100. So when we see 3 over y is equals to 6 over 100, alright, what do we see here? Now this is where the questions get a little bit tricky. Instead of a direct comparison like what we have in the tens place, now in this hundreds place, you realize that the numbers are actually slightly different. So you need to use your understanding of equivalent fractions to help you to find the value of y. Now from 6, how do I get a 3? I need to divide by 2. So by the concept of equivalent fraction, we know that for the denominator, we will also need to divide by 2. And so that's where we will be able to find the value of y, which is 100 divided by 2. That gives us the value of 50. So for this question, the value of x will be 2 and the value of y will be 50. Alright? Okay, so this will be question number 1. It's a sort of a warm-up question. Now let's go on to question number 2. Now these questions are actually questions that were taken out from school exam papers. Alright, so and these are normally the commonly asked questions for P5. So for students who are in P5, this probably will be the first time that you're taking a full paper. Alright, so it's also good for you to know that some of the commonly asked questions related to the topics that's going to be covered in your exams. Okay, now for the second question, we are looking at this is related to whole numbers. Alright, let's read the question together. So Tammy bought an equal number of pears and mangoes. Alright, so let's underline the keyword here, equal. There are two different types of fruits here that we're talking about, pears and mangoes. Now the pears were sold in bags of 3. So in bags of 3 for $2. Alright, and mangoes, okay, this is pears. Now the mangoes were sold in bags of 4 for $5. Alright, so this is the second information that we see, which is also represented in the picture below. Then next, he paid $28 more for the mangoes than the pears. Alright, so how much did Tammy pay in all? So that is what the question is asking for. So now, where do we start for this question here? Now we need to take note that first clue here we see is equal number. Now to buy an equal number of pears and mangoes, we need to find the lowest common multiple of the quantity of fruits here. Alright, so if we look at it in this question, we will need to find the lowest common multiple of 3 and 4, which is the quantity of the fruits. Alright, so the lowest common multiple, LCM for short, of 3 and 4 will actually be 12. Okay, so understanding that, let's take a look at the pears. So for pears, alright, it is sold at 3 pears for $2. Now, how many groups of 3 is needed to make 12? Alright, we know that we can get 4 groups of 3 to make 12 pairs. So that's where we will multiply by 4 here. So then we can get 12 pairs. And we will do the same on the right hand side for the value of it. So when we multiply by 4, we will know that 8 pairs actually will cost 12 pairs will actually cost $8. Alright, now for mangoes, let's take a look at mango. Now for mangoes, it is sold at 4 mangoes for $5. Alright, so if we look at this, so in order to get 12 mangoes, again, we will need to multiply by 3 to get 3 groups of 4. So the same on the right hand side. And we managed to find for 12 mangoes, it will cost $15. Alright, so having found this, what do we do next? Now if we look at the question, the next clue says that he paid $28 more. Now be careful, when they say $28 more, it is actually referring to the difference instead of the total amount of money that he spent. Alright, so we need to take note of this. Why? Because with this, it will direct us to the next step where we will find the... Alright, so now we know that the total price difference, alright, between the pears and the mangoes bought, alright, is equal to $28. And so next we want to find the price difference between 12 pears and 12 mangoes. Alright, so price difference of one group of 12 pears and 12 mangoes will be equals to $15 minus $8, and that gives us $7. Okay, so now to find the number of groups of 12 fruits that were bought, alright, we will take 28 divided by 7, and that gives us 4. So this 4 actually tells us that this is the groups of 12 fruits. Alright, so 12 pears and 12 mangoes that were bought. Alright, so we found out that the number of groups that were bought is 4. So what's next? So next, we are supposed to find out how much did Tammy pay in all. So we will find what is the cost of one group. It will be $8 plus $15, as we have found over here at the top here. Alright, so we know that the cost of one group is actually $23. And with this, we can find the total cost. The total cost that of 4 groups will therefore be 4 multiplied by $23, and that gives us the answer, which is $92. Alright, so for this question, it is a very common question asked in P5 exams, school exams. Now, variations to this question. In this question, they mention that it is an equal number of pears and mangoes. Possible variations can be that the question may tell you that he spent equal amount of money. So they change the value to be equal. So we need to understand the question, read the question carefully to decide which is the number that you will use, or which is the variable that you will use to make the same, or to find the lowest common multiple. Alright, so be careful when approaching this question. You need to understand whether is it equal number or is it equal value to allow you to make the to find the correct lowest common multiple. Alright? Okay, so with that, let's go on to the next question. Okay, question number 3. Again, another question that is related to whole numbers. Alright, let's read the question together. Now, question 3 reads, Belinda needed 210 pieces of wires. Now, each length is of 0.8 meters. The wires were sewed in rows of 13 meters each. So, what was the least number of rows of wire that Belinda needed to buy? Now, let's take a look at the question. Alright, so first we know that Belinda needed 210 pieces of wire, and each piece of wire is of length 0.8 meters. Okay, so this is the first clue that we have. And next, we know that the wires were sewed in rows of 13 meters. Hang on, can't seems to write. Okay, so in rows of 13 meters, alright, each. So what was the least number of rows of wire that Belinda needed to buy? So how do we approach this question? We need to understand, alright, so she needs 210 pieces of wire, each of length 0.8. Common mistake made by a lot of students is that they will take 210 multiply by the length, which is 0.8, and they will try to find and divide it by 13 to get the number of rows needed. Now, we need to think carefully, alright? That is not the right train of thoughts, but instead, what should we do? First, we need to ask ourselves, for each row, alright, for each row of 13 meters, how many 0.8 pieces can it be cut into? Alright, so then that will tell us of the first steps that we should take. So let's find the pieces of wire in each row first. Okay, so how do we do that? We will take 13 meters divided by 0.8. That will give us 16.25. 16.25. How do we then decide? Can we buy can we have a piece that is of 0.25? No, we can't do that. So the pieces has to be in full 0.8. Okay, so in order to get that, we can probably at most get 16 pieces of length 0.8 each from one row of the wire. Okay, now then we need to find if each row of wire of 13 can give us 16 pieces of wire each length 0.8. Now we need to find out the number, alright, the number of rows needed by Belinda. Alright, to find the number of rows needed by Belinda, I will take 210, the quantity that she needs, divided by 16, which is how many, the quantity that can be cut from one row of wire, and we get 13.125. Now, 13.125, what does that mean? Alright, so in order, if I only buy 13 rows of the wire, 13 rows of wire will probably only give me lesser than 210 pieces, which is not what Belinda need. Belinda needed 210. So in order to do that, I need to buy one more extra row, and so that's where, alright, the number of rows needed by Belinda means that I need to take 13 rows plus another one more row to cover that partial that is needed there, and that tells me that Belinda needs to buy 14 rows. Alright, so this is how we actually should approach this question. Alright, so I'll give a few seconds for you to digest the question before we go on. Alright, so now let's go on to question number 4. Okay, question number 4 is a question related to the topic of geometry. Now, geometry is a very important topic as well. Okay, because it actually will it constitute to quite a big part in your exams also. So some of the common questions that we ask here, because you have learned all your angle properties, your geometrical shapes, the angle properties of geometrical shapes like rhombus, like a trapezium. You know rules that you have, like angles on the line, alternate angles, corresponding angles, and as well as opposite angles within a four-sided figure. So these are the key properties that you need to know, all right, in handling questions related to geometry. Okay, so now let's take a look at this question that's related to angles. Now in the figure, PQTU is a rhombus and PQSU is a trapezium. Okay, so now let's revise, let's recap. All right, so for rhombus, what are the properties that you have for rhombus? Okay, it has two pairs of parallel lines. Okay, and we all know for rhombus all sides are equal, are of equal length, and we also know that the opposite angles are equal. Okay, so these are the properties of a rhombus. Now let's take a look at trapezium. Okay, trapezium is actually very simple. It just has one pair of parallel lines. Okay, now let's identify where are the rhombus. So in this figure here, the rhombus is actually the one that I highlighted in yellow. This is the rhombus. Okay, now how about the trapezium? Where is the trapezium in this figure here? So the trapezium will be the one that I've highlighted in orange. This is the trapezium that you can see. Okay, so the one highlighted in yellow is the rhombus as indicated in the question, and the one in orange is the trapezium that is mentioned in the question as well. Okay, so understanding that, now let's take a look at the second part of the question. USR is a straight line, so USR is the line below, and we know that UPQ is actually equals to 106 degrees, whereas UPQ is indicated here, and QSR is equivalent to 108 degrees. That's on the right hand side there at the corner. Now what are we supposed to find? We are supposed to find angle PQU. Where is angle PQU? Now angle PQU is actually this little angle here that we see. Okay, alright, so now what do we do next? How do we start? Now let's take a look at, okay, let me erase the highlight. Okay, so let's take a look at triangle PUQ. This triangle here that I highlighted. Okay, if we look at this triangle that I just highlighted, first, because PQTU is a rhombus, we know that these four sides are equal. Now, when we know that these four sides are equal, when we look at triangle PUQ, we will realize that it is actually an isosceles triangle. Okay, so this is the first clue that we know. At triangle PUQ is an isosceles triangle. Now, when it is an isosceles triangle, what does that tell us? Very important property of an isosceles triangle, the base angles are equal. Okay, and in this case here, you will realize that actually one of the base angle is actually the angle that we are looking for, which is PQU. All right, which is the one that is in blue. All right, at the corner there. So now we know that in order to find angle PQU, we will have to take 180 degrees minus 106 and divide by 2. Okay, this is because it is the base angle of an isosceles triangle. Now, make it a good habit to always write the reasoning behind your step so that you will show to the marker very clearly that you know the property that you are applying to get the answer here. So in this case, when we work out the question, all right, it will be 74 degrees divided by 2, and so we can find that angle PQU is actually 37 degrees. So that is for part A. All right, so we have solved part A. Now let's take a look at part B. Part B, we are supposed to find angle TQS. Angle TQS. Where is angle TQS? Okay, angle TQS is actually this angle that, oops. Okay, let me use a different color. Okay, the one in red, this is angle TQS that we are looking for now. Now, in order to do that, what do I need to first find? Okay, let me fill in the angles that we found. This is 37 degrees. Okay. So, in order to find TQS, we need to first find a few different angles. What are the angles that we need to find? All right. So, we need to find this angle here. How do we know this? What is this angle here? Now, remember one of the properties that we learned for rhombus, the diagonal actually cuts the corner angle directly into half. So, which tells us that angle, all right, the angle here, which is angle UQT, is actually equals to the angle that we found earlier, which is angle PQU, and it is equivalent to 37 degrees. So, we know that this is 37 degrees. Okay, so once we know that this is 37 degrees, what happened next? Now, take a look at the highlight in green. You will realize this is a parallel line. This is also a parallel line. And there's this line here that cuts the parallel line, cut across the two parallel lines. Now, this green color, all right, the green color highlighting that I've shown actually show a very important geometrical property, which is called the alternate angles. Okay, alternate angles. Okay, let me highlight this part here instead of that one to make it very clear. Okay, so this forms two parallel lines that cut across, and it forms an alternate angle. So this angle here is actually equivalent to 108 that you see over there. Okay, so we know that angle PQS is actually equivalent to angle QSR, and it is equivalent to 108. So this is alternate angles. Knowing this, what do we do next? If I know that this whole big angle here, okay, in purple, that is actually 108, now I can use this to help me to find the angle that I'm looking for, which is angle angle TQS. So therefore, I know that angle TQS will be equivalent to 108 degree minus 37 minus 37. Okay, and that will give me 34 degrees. So this is how I make use of the different geometrical properties and angle rules to help me to solve this question here. Alright, so key thing important that you need to take note when you are reading the question, keywords like rhombus, trapezium, straight line, all this gives you clues that you can use to help you to solve the question and find the unknown angles. Alright, so make sure that you remember all the properties that is related to each of the shapes that were taught to you. Okay? Now let's go on to the next question, question number 5. Okay, question number 5 is another question on geometry. This time round, this is a very popular type of question also. We call it the folding paper question. Alright, so you look at the question here. It reads, a piece of paper in the shape of an equilateral triangle EFG is folded along the dotted line EH as shown, and you are supposed to find angle X. Okay, so they show the picture below, before folding and after folding, along the fold line, which is EH, the dotted line there. Now, first, let's take a look at the first sentence. What are the properties of an equilateral triangle? Okay, so very clearly, equilateral triangle, we know all sides are equal. And another important property is that all interior angles, interior means inside. So interior angles means the angles inside the triangle, they are all equals to 60. Okay, so this is 60, this is 60, and this is 60 as well. So knowing that, now we fold the triangle as shown in the diagram, we will get the second picture, the picture on the right. Imagine with me, if I were to unfold the paper, so the triangle will be like that. This is 60, this one is 60, and this one will be 60. Am I right? So when you visualize this with me, you will realize that this point here is actually the point F over there where it's folded down. Am I right? So with that, once we know that, we can visualize this, we will realize that this angle at the corner here is actually 60 degrees. Okay, so once we know that this is 60 degrees, what does that tell us? Can we find this angle here now? Okay, we can find this angle. So angle HEF will actually be 180 minus 102 minus 60. Okay, which gives us 18 degrees. Now this, what property are we looking at in this case? Okay, this is actually sum of interior angles of a triangle equals to 180. Okay, sum of interior angles of a triangle is 180. So using this property, I find that angle HEF is 18 degrees. So knowing that, because it's folded, a mirror image of it, so that means also that this angle here is also 18 degrees. So knowing that this angle here, when unfolded, it will also be 18. And we know that the whole total of that angle in the corner is 60 degrees. So therefore, from here, we can find angle X to be equivalent to 60 degrees minus 18 minus another 18. Alright, and that gives us 24 degrees. Okay, so that is how we solve question 5 over here. Okay, you realize that Coach Jeremy actually covers quite a few questions on geometry, because I understand that most of the schools, geometry is taught in the second half of the year, and therefore usually in your end of year exams, that's where probably there will be a few more questions on geometry, alright, than the other topics. Alright, so it's good to take note and be aware. These are the 3 commonly asked questions related to geometry. Now let's take a look at the next question now. Go on to question 6. Okay, for question 6, it is a seemingly easy questions, but it's actually quite tricky. It tests you on your understanding of the concept of area of triangles. First, alright, let me just recap with everybody. To find the area of a triangle, remember the formula? Now the formula to find the area of triangle is actually equals to half base multiplied by the height. Okay, remember, base and the height in this case must be perpendicular to each other. Alright, so must remember that. So knowing that formula, now let's take a look at the question here. ABCD is a big rectangle formed by 2 smaller rectangles. Alright, so AXYB and XYCD, these are the 2 rectangles that you see there, divided by the dotted line. So now E and F are points on XY. Okay, and the total area of the 2 shaded triangle is actually 16 square centimeters. We are supposed to find the area of the rectangle ABCD. So how do we see this question here? Okay, now in order to understand this question, let's take a first. I need to ask for the first triangle on top. We will realize that this is actually the height. Let's call it H1. Okay, now H1 is the height of the first triangle. And of course, this will be the base. Okay. Now for the second triangle at the bottom, this will be the height of the triangle. Let's call it H2. Alright, H2 will be the height of the triangle DEFC. And of course, this will be the base. Now, if we take a look at the 2 triangles, what is one thing that is in common? You realize that the base of these 2 triangles are actually the same. Okay? And if we look at the height, we will realize that actually H1 and H2, they add up to form the height of the whole rectangle. Okay? So that is something that we establish here from the information given in the question. So we know that H1 plus H2 is actually equivalent to the height of the rectangle. Now that is helpful later. So let's take a look at the first triangle first, the one on top. So to find the area of triangle ABE, we know that it is half times the base plus times H1. Okay, and next, area of triangle DFC will be half times base. Now take note, I don't need to differentiate my base because they both have the same base. Alright, so we notice that the H1 and H2 we established earlier that it adds up to become the height of the rectangle. So keep those thoughts in mind. Okay, so now let's find the total area of the 2 triangles. So the total area of the two triangles will be half base H1 plus half base H2. Alright, so if we take out the common factor there, we will know that it is half times base times H1 plus H2. Now remember, earlier we established the fact that H1 plus H2 is actually the height of the rectangle. So I replace that with the height of the rectangle. So once I know this, take a look at this. So the total area of the two triangles is actually half the area of the whole rectangle. Now can you see the link now? So once I have that, I know that the area of the two triangles is actually 16 square centimeters. And this 16 square centimeters is actually half the area of the whole rectangle. So therefore, to find the area of the rectangle ABCD, all I need to do is to take the area of half of it, the two triangles, I multiply by 2, and therefore I get the area of the whole rectangle ABCD to be 32 square centimeters. Alright, so this is how we solve this question. Now the trick in this question is this. You need to be able to see that the heights of the two triangles actually add up to form the height of the rectangle. Alright, so that will be the connection point to help us to see that actually the total area of these two shaded triangle is equivalent to half of the area of the whole rectangle. Okay? Alright, so this is how we see this question. Alright, next, let's go on to question 7. Question 7 is another question on the area and perimeter of triangles, but there's a twist to it in part B. So now let's take a look at the question first. In this question, it says that Leo had two identical right angle triangles that's shown in the figure there. He arranged them to form figure QPRST. Alright, so QP is actually 25 centimeters and ST is actually 20 centimeters. So the perimeter of the whole figure is 120 centimeters. So we are supposed to find the length of RS, which is here. Now, first we need to confirm the understanding of the perimeter of the figure. Now, what do we understand from perimeter? Perimeter means the outline, length of outline. Alright? So if we look at this picture here, the length of the outline will actually be like this. Okay, so this forms the perimeter of the figure. And we know that the perimeter of this whole figure adds up to be 120 centimeters. So what should we do next? Let's find out similar, because they are both two identical right angle triangles. So let's try to find if we the length of each side of the triangle, except for the one that we are supposed to find. Okay, so if we look at it, we know that PQ is actually the same as RT. They are the hypothesis. We call it the hypothesis of the triangle. So we know that this is 25 centimeters. Now, which length will be the same as ST? It will be RQ. So we know RQ is 20 centimeters here. So now, what is missing? PR as well as RS. And these two are also identical length. Alright, so we know PR and RS, they are identical. So having known this, let's find out the perimeter. So the perimeter of the figure will actually be equivalent to 25 plus 20, alright, plus the question mark, which I'm not sure, which is PR, and then another question mark, followed by another 20, and another 25. So this is, it all adds up to be 120. Alright, So when we add up all the numbers, we get 90 plus question mark plus another question mark, and that gives us the length there. Okay, so of course we know that the question mark is actually the two dimensions that we mentioned. So it's PR and RS, which is identical. So now therefore we know that PR plus RS will be equals to 120 minus 90. That gives us 30. And since PR and RS are identical, so to find RS, which is the one that we want, we will take 30 divided by 2. That will give us 15. So RS is actually 15 centimeters. Alright, so this is the answer for part A. Now for part B. Part B is the one that is slightly tricky. So we know that Leo had a rectangular piece of paper measuring 180 cm. Oh, I have a question there that says that how do we get the questions for the children, for the child to try? Well, maybe you can leave your contact number or wait for the past year papers to come out. Yeah, all right. So don't worry. Now let's continue with part B. So Leo had a rectangular piece of paper measuring 180 cm by 85 cm. Now he wanted to cut more of such right angle triangles from the paper. So the clue here is you want to cut more. Alright. So what is the greatest number of triangles he could cut from the paper? Alright, so visualize with me. So you have a rectangular piece of paper like this, a big piece. Okay, and if we look at the two triangles, we can actually, alright, place the two triangles and form a smaller triangle in this way. Alright, where the dimensions are 20 and 15. Or we can also put it in this way, 20, 15. Okay? So there's two ways that we can put orientate the rectangles. Alright, so basically the two triangles form one rectangle. So now on the bigger piece of paper, which measures 180 centimeters by 85 centimeters, how many of such small rectangles can I cut out from this bigger piece? Okay, so the key thing is this. Common mistake made by many students, what they will do, they will find the area of the big piece of paper and then they will find the area of the small rectangle and they will divide, you know, hoping to get a number. You probably will get a number. But that is not the right way to solve this question. Why? If you think of it logically, in a practical sense, if you have a big piece of paper and you need to fit as many of the small rectangles inside, there will be sometimes empty spaces or that is wasted that you can't really cut out or form another rectangle. So this is the idea that is tricky here in this question that will cause many of the students to lose their mark. So the right way to approach this question is like what I will explain now. So there's two possible scenarios. Scenario 1 is when I put, this is scenario 1, when I put the rectangles in this way. Alright, so basically it looks like that. Okay, so I have 20, 15, 20 and 15 here. Alright, so I don't know how many I can put along the length and along the breadth. Okay, so this will be scenario 1. And scenario 2 is when I put the rectangle. Okay, let me use another color. I put the rectangle in a different orientation in this way. So it says 15 and 20 here. Okay, and so on. Okay, so in these two scenarios that we see here, okay, let's find out how many of each rectangle can be cut out. Let's take a look now. So scenario 1, if I were to divide along, let's take a look at the length. which is 180 centimeters, and how many can I fit in along the length? Okay, so I will take 180 divided by 20, I get 9. Meaning to say, the first scenario, when I orientate the rectangle in that way, I can put 9 rectangles along the length of the bigger piece of paper. And how about the breadth? The breadth is actually 85 centimeters, and I divide it. Alright. Okay, you can actually divide it by 15, which is the breadth of the smaller rectangle, and you will get 5. You can put 5 of them, but there is a remainder of 10 centimeters. So what does it mean there? So if I were to follow the first scenario, you will realize that at the bottom of the bigger piece of paper, there will be one space there, which is of 10 centimeters height, 10 centimeters breadth, that you can't use. You can't use it to cut any more rectangles. Okay? So in this case here, for scenario 1, the total number of smaller rectangles that can be cut out will actually be 9 times 5, which gives us 45 rectangles. So that will mean the number of triangles will be 45 multiplied by 2. That gives us 90. So this is scenario 1. Now scenario 2, the length is actually, along the length now, I can actually take 180 divided by 15. That will give me exactly 12. For the breadth, alright, for the breadth, it will be 85 divided by 20. Okay, when you have 85 divided by 20, you can put exactly 4 rectangles along the breadth, and there will be a remainder of 5 centimeters. Excuse me. So now in this scenario 2 here, when you look at the number of smaller rectangles, it will be 9, okay, you have 12 multiplied by 4, that gives us 48, and therefore the number of triangles for scenario 2 will be 48 times 2, that gives us 96. Now let's compare scenario 1 and scenario 2. The number of triangles in scenario 1 is 90. So if I place it that way, I can cut out 90 triangles. But in scenario 2, if I place it this way, I can actually cut out 96 triangles. So if I compare these two, according to the question, the condition is that it must be the greatest number of triangles that he can cut out from the paper. So which scenario should we pick? We should pick scenario 2. And so therefore the question, the answer to this question will be, we will play the greatest number of triangles that he can cut out from the paper is actually 96. Now common mistakes by students. First, the first one that I mentioned about, they will take the whole area of the area of the whole big piece of paper, rectangle, and they divide it by the area of the smaller rectangle, and they try to get the number of it. But that way, it will definitely not be right, because there will be the wasted space that we have found in each of the scenario that can't be cut into that rectangle. Alright? And the second mistake that students will make is that they use scenario 1 and they are very happy and they stop there. They did not consider scenario 2, and therefore they don't know that the correct answer is actually 96. They can cut more triangles using scenario 2. So when we approach the question, we need to be very careful. Always seek to check different possibilities and therefore find the correct answers. Alright, so this is how the right way that we should tackle this question. Alright. Okay, let's go on to the next question. Okay, for the next question, question 7, we will go on to, question 8. We actually go on to another topic, which is fraction. It's another major topic that it will be tested in your P5 end of year exam. So take note, this is also a very commonly asked type of question. Alright, so the question reads, a fruit seller bought some plums. He threw away 27 plums and that were damaged. And after selling 310 of the remaining plums, he was left with 42 plums bought. Alright, so how many plums did the fruit seller buy at first? Now let's take a look at this question here. So we know that he threw away 27 of the plum, alright, and selling 310 of the remaining, he's left with 42. So how many did he buy at first? So these are the clues to the question. So what should we do here? Now, I'm sure in schools, teachers will have taught all the students there to use this method called the branching method. So as the name suggests, we are supposed to draw out the branch. It's like a tree that's branching out, all right? So how do we always start with the total. Total is always the one at the beginning. All right, so in this case here, we can get the total from the fraction that's given. The denominator usually will represent the total. So in this case, we know that the total is 7 units. Let's put it there first based on the question given. Now, first branch will be those that were damaged. Alright, so for those that were damaged, we know that it is 7 out of it. So if the total is 7 units, that tells us that the damaged ones will be 2 units. Alright, next, the other branch will be whatever that is remaining. Okay, so with this 7 units, and I'm sure we know that the remaining will be 5 units. Alright, so this is what we have established based on the first line, second sentence that is given in the question. Now let's take a look at the third sentence. So after selling 310 of the remaining. So now from the remaining, I will further branch out. I have one branch that is sold. And this is actually 3 units. And the other branch that is left, all I know from the question is that it is 42 plums left, the whole number, the value of it. So how do we now actually establish the connections in this case? So we know that the fraction, all right, for the remaining, in this case, the denominator is 10 units. But we do see that the remaining here is only 5 units. So what do? We will make it the same because they represent the same thing. So in order to do that, I will multiply by 2 for the remaining units. That gives me 10 units here. So when I do this, I will do it the same for all to make it equivalent. So I will multiply by 2 for this, the damage also part as well. So that will give me 4 units. And I will multiply by 2 for the total. That will give me 14 units. So notice the number of units in red represents the one that has been so-called made the same throughout. Alright, so then that's where we can compare the 3 units to the 10 units to the 14 units to the 4 units. They are all of the same now. Okay, so with that, that also informs and tell me that what is left is actually 7 units. How do I know it's 7 units? Because 10 units is the remaining. I minus away the 3 units that were sold. So what is left will be the 7 units. So once I establish this branch diagram, it is clear for us to see that the connection, it happens where? It happens here. Alright, the one that I have just boxed up for you to see. You will see that, alright, 7 units will actually be equal to 42. So that's how I establish the connection. And from there, I can find 1 unit, which will be 42 divided by 7. That gives me 6. And finally, what does the question wants me to find? The question wants me to find how many plums did the fruit seller buy at first. So at first, it's actually this part here. Okay, which is 14 units. So let me find the value for 14 units. It will be 14 times 6, and that gives me 84. So it means that, alright, the fruit seller actually buy 84 plums in the beginning. Alright, so that is what we have for question number 8. Now let's go on to question number 9. Okay, question number 9 is again another question on fractions. Now Lily had 56 clips fewer than Pat. After Lily had used 3/4 of her clips, Pat had 167 more clips than Lily. So how many clips did they have all together at first? So first key thing, 56 clips fewer. Alright, so let's draw the model. Okay, so we know Lily and Pat. So who will be longer? Since Lily had fewer than Pat, Lily will be the one that's shorter, while Pat will be the one that will be longer. And what is the difference? We know this is 56. Alright, next. Alright, for those who had missed the earlier question, later maybe if there's time, I will scroll back to question 8 for you to take a look. Now for question 9, look at this. Second line, it says that Lily had used 3/4 of her clips. So that tells me that for Lily, I will cut it into 4 equal parts. And out of the 4, 3 were actually used. Now when we cut Lily's bar into 4 equal parts, if you take a look at Pat's bar at the bottom, it is actually equivalent to the part that's equivalent to Lily. We can do the same, make it equal by cutting it into 4 equal parts as well. So once we have that, we know this is 1 unit, this is 1 unit. Now we can start to fill in all the information that is left in the question. So Pat had 167 more clips than Lily. So that's after Lily used up. So we are comparing from here all the way to the end. So this whole part here is the difference, which is 167 more that Pat had more than Lily. Okay, so this is after Lily had used up the 3/4 of it, which is the 3 shaded ones. Alright, so from here we can, if we look at this, you do realize that this part here is actually 3 units. And straight away we can connect the 3 units will be equivalent to 167 minus 56. Okay, so from there I know that 3 units is 111. So 1 unit will be 111 divided by 3. That gives me 37. So now, what does the question want us to find? How many clips do they have all together at first? So all together, so I know that at first there will be 4 units for Lily, and let's find for Lily first. At first, so Lily at first, it will be 4 units, so it will be 37 times 4. That gives us 148. Now for Pat, at first, it will be whatever, the 4 units plus another 56, and that will give us 204. So therefore, all together, at first, they will have 148 plus 204, and that gives us 352. So this is the answer for question number 9. Alright? Okay, good. We are now going into the last question. Okay, this last question is a question related to the topic of percentage, which I believe many of you in your schools, you will have also learned this. Now, let's quickly take a look at this question here. Now, question 10 reads, Brian and Clara, 2 different people, each paid $72 from some donuts from the same store, for some donuts, alright? So, Clara used a 20% discount coupon at the shop. So, because of that, that means that Clara has more money than Brian in the beginning. So, after that, after the 20% discount. So she used the savings that she got from the discount to buy more donuts. And in the end, she got 6 more donuts than Brian. So what was the price of one donut? Okay, how do we approach this question here? So we know since there is a 20% discount for Clara, that means to say $72 is only 80% of the amount of money that Clara is supposed to pay. Alright, so from there, I know that 10% will be 72 divided by 8. That gives us 9. Okay, and I will find 20%. That is the amount of money that is saved for Clara. So it will be 2 times 9, which is $18. Okay, what does this $18 means? This $18 means that when Clara paid $72 for the donut, and she used the 20% discount, she saved $18. And this $18 actually got her another 6 more donuts. Alright, so from there, we can connect that the cost of 6 donuts will actually be $18. So therefore, the cost of 1 donut will be 18 divided by 6. That gives us $3. So each donut costs $3. And that is how we get the answer for question A. Alright, now for part B, how many donuts did Clara get? Okay, so you need to understand. So if this is 80%, $72 is actually only 80% of Clara's money. So therefore, to find out the original amount of money that Clara have, which is 100%, alright, we know that it should be 10 times $9 for each 10%. So therefore, we know that this is the amount of money, alright, that Clara had at first. So with this amount of money, the total number of donuts bought by Clara, alright, by Clara will be 90 divided by 3, which is, 3 is the cost of each donut. And therefore, we find that Clara actually bought 30 donuts. So this is the answer for question 10. Yeah, okay. So, yeah, so this is the answer for question 10. And I am going to scroll back to question 8 because I think somebody requested for it to see that again. So I'm going to scroll back to question 8 now. Alright, so this is question 8. Okay, take note. We have to draw the branch diagram correctly. And remember, we always seek to make the units the same so that we can compare them on the same level. Alright, so yeah, so this is question number 8. Okay, so I hope that everybody has gained some insights, into what you are expecting to see in your P5 end of year math exam. I hope all of you in your preparation, alright, you can also do well for your upcoming exams in a few weeks' time. So we have come to the end of the live. So if you're wondering where to get these type of questions, you can find them in our OnSponge books, or alternatively, you can wait for past year papers. Alright, so thank you everyone, and I'll see you all again. Bye bye.